So we're going to do 3.5 numbers 22 through 25. Just remember that these are really good review problems. So for those of you who are studying for your final, it's a good idea to go back through some of those Go problems you never did and just make sure that you understand them. All right, so here goes 10 to the 4x plus 1 equals to 215. So we talked about how to either, number one, rewrite this using logs or undoing the exponential. So if I did rewrite this using logs, right? So if I did rewrite this using logs, remember that log base b of y equals x, I don't know. And then so we go b to the x equals to y. I think I use different letters every single time. So then if I was to rewrite this using my logs, I would say log base and then use that same base 10. So that would be log base 10, which again, I don't have to write 10, but I'm going to write 10 so it's very clear to you where this 10 quote unquote went. And then these two guys switch places. So then that's log of 215 equals to 4x plus 1. Right, and I need you to think about this as a number that I can punch into my calculator. Okay, so then here on the x side, I want to solve for x by undoing all this stuff. So again, I'm going to be using SADMAP right here. So I see subtraction, so I'm going to subtract. I'm going to write it as -1 plus log base 10 of 215 because I like it that way better. Whenever you put the -1 in the back, some people are not very clear on whether it should be subtracting 1 then taking the log or not. Here it's very clear. I'm going to subtract 1 after I take the log, right? Because he's all the way outside. Okay. So then I'm going to just divide by 4. And the 4 goes over the whole entire thing. So that's what x is equal to. It's equal to this number, -1 plus log of 215 all over 4, which is approximately, right? Let me just plug that in here. So we're going to put parentheses for my numerator, -1 plus log 215. Again, I don't have to use base 10 because that's what log is in. And then divide that whole thing by 4. So it's approximately 0.33. Yeah, it's approximately 0.33. Okay, so if you wanted to check your answer, one easy way to do that is plug in this side, plug in this side, and they should cross when x is equal to this number right here. So just for your sake so that you can see, I'm going to put parentheses around my whole exponent so that it stays there. And then this is y equals to 215. And you're like, Ms. Johnson, nothing happened. And I say, I know, because 215 is way off the scale there. So I'm going to zoom out. There it is. So here's where they intersect. And I want to get in closer here so I can actually get a really good intersection. So here, if I click on that point, I got 0.33, which is exactly what I got here. And it's going to be an approximate because it's not perfect, right? So there you go. That's how I check my answer. Okay. Because I rewrote here, I'm probably going to take the log of both sides when I get to this part right here, just so that you guys can see the difference between the two problems and see which way you like better, right? All right, just to start us off, I'm going to be using SADMAP on the side that X is on. Do you see any subtraction or addition on this side? And you're like, yeah, it's -3. So then we would add 3 to both sides. And we got 10 to the X divided by 5 equals to 24. So we did subtraction addition. The next thing, division and multiplication. Do you see any division or multiplication on the X side? And you're like, yeah, that divided by 5. Very good. So how do you get rid of divided by 5? Yeah, you'd multiply by 5. Multiply by 5. Oh, really? Give me a second. I'll fix that. Oh, okay, perfect. So times by 5, done. Right? And then, so that is, what is that going to be now? 10 to the x is equal to 120? Is that right? 120? Yeah, that seems right. Okay, so this part is I'm going to do it differently. So if you like rewriting this in terms of logs, that's what you would do right here. But I'm going to I'm going to do something differently just so that you can see what the difference is and see which way you like. So I'm going to rewrite it again. So 10 to the x equals to 120. And then I ask myself, okay, well, how do I get rid of, so I'm in E for exponent, right? How do I get rid of this exponent in the top? Well, if I take the log of both sides, right? If I take the log of both sides, if you remember, you guys all figured out that when the base and the argument are the same, this equals to 1. So this x can jump out in front using our power rule, right? So this is just going to be x is equal to log of 120. So again, checking my answers, I would do the same exact thing. I would plug in. Let's see, let's get rid of these guys. So I would plug in the left side. So I'd go 10 to the x divided by 5 minus 3. And I have that thing. And then I also have y equals to 21. Okay. And so I'm going to go back to my home screen. I'm going to look for 21. Oh, there it is. This is where these two intersect. And this is my answer, 2.079. And you're like, wait a second, Ms. Johnson, you didn't get that answer. You got log of 120. Okay, so let's plug in log of 120 and see if we get that same approximation. And some of you are like, oh, Ms. Johnson, it's almost right. And it's like, yeah, but Desmos can only keep so many, decimals for you. So there's our answer, log of 20, which is approximately 2.079. So I'll write that down. Okay. So the same thing would happen for number 24. So I'm going to have you guys practice this one on your own, and then we'll check the answer together. But I did want to jump over to this number 25. It says, given that f of x equals to this crazy thing, select all the functions that are equal to f of x. So they're asking you to use all of your different log properties to condense this thing to see if you can get something smaller. So if you remember, this right here, subtraction means division, right? Subtraction means division. So I recognize that this division right here looks like log base 3 of 729x divided by 3. If you want to do it like this, right? But that's not closer to any of those, right? They're trying to make you think it's this one, but it's not, right? So B is definitely not an answer. He is a distractor. They call it distractors. When you're taking a test, the answers that look right, but are wrong, are called distractors. Okay. All right. So that helped me with that. I do recognize this one, log base 3 of 3 is 1. So that's just 1 right here. Right. And 729 seems like it's a power of 3. So I'm going to play with my calculator to try to get me to 729. So I say 3. I already know 3 cubed is 27. So I already know 3 times 3 times 3 is 27. Times 3 is 81. Times 3 is 243. Times 3 is 729. So how many 3s was that? So 1, 2, 3, 4, 5, 6 of them. So I can rewrite 729. So I can rewrite this to log base 3 of 3 to the 6th times x, right? Minus 1, right? Because we already figured out this is 1. So this has log base 3 of x staying, but where does this guy go? So I'm going to rewrite this as log base 3 of x, 3 to the 6th plus log base 3 of x minus 1. So this log base 3 of x business right here shows up as soon as this catches up. Give me a second. There it goes. Right? This matches with this. So now what I'm going to do is I'm going to simplify this, and you could see the power rule happening here. So this 6 can jump out in front, right? So we get 6 times, and then this log base 3 of 3, again, that's just the number 1. So that's 6 times 1 plus log base 3 of x minus 1. So 6 times 1 is 6, minus 1 is 5. So then, therefore, my answer is 5 plus log base 3 of x, which does match this, right? It matches that really well. So I'm going to circle A for sure. Okay, let's see. This one right here, let's do C. This one right here, I'm going to try to play with the numbers there so that I can get back to here. So since I simplified this already, and this is the simplified, I'm going to take this and try to simplify it instead of trying to make this look like this, if that makes sense. So I'm going to simplify this. So here I got log base 3 of 3 plus log base 3 of x. You see what I did there? I used the multiplication rule. So if it's multiplying here, oh, it's not showing up. Hold on. Oh, it's really slow right now. Let me pause it really quick. Okay. So it finally showed up, and it's log base 3 of 3 plus log base 3 of x. So this very first part right here, I just use the multiplication rule, which is if it's multiplying here, then it's adding out here, right? And I'm going to do the same thing here. I'm going to simplify log base 3 of 9. Log base 3 of 9 to me is 3 to the what gives me 9, and that's 2. So that's 2 times 2. Okay, so this guy here is equal to 2. So that's plus 2 times 2, which we all know is 4. And if you didn't know, that's okay too. All right, log base 3 of 3, we're already talked about, it's the number 1. So I got 1 plus 4, which is 5. So I got 5 plus log base 3 of x, right? Which is the same as this. And if this is the answer, then so is C. You see what I'm doing there? I'm kind of like making, since I already know one of them, I'm going to like make all of them equal to that. Okay, this next one. I already see log base 3 of 3, that's 1. I already see log base 3 of 9. We said that was already 2. Half of 2 is just 1. So 1 minus 1, that's 0. So this first part is 0. So now I need to simplify this to see if I could get that to be this, right? So this is 0 right here. So now I'm going to take care of this part. So this part here goes like this. So I'm going to go log base 3 of 243 plus log base 3 of x, right? Okay. And the log base 3 of x looks good right here. I just need to figure out if this is 5. And we already figured out some powers of 3. And to get 243 right here, I needed 1, 2, 3, 4, 5 3s. So this is equal to 5 plus log base 3 of x. So yeah, this one works too. Okay. So all your answers were A, C, and D because all three of these simplified to this thing. All right, beautiful.